Here is a 3D simulation of my project. The hygrometer has to be changed quite often, which is why it is detachable. Here is the circuit, which is connected to the Arduino and also has two LED lights to indicate moisture levels. The pump is connected to the on and off switch as well as the motor driver. The final component is what connects the hygrometer to the Arduino, which is connected to analog 0. This is the block diagram for my project. When the soil is dry, the hygrometer sensor reads low moisture and will tell the Arduino to turn the power on to the motor driver. Even if the motor driver has power, the on and off switch must be turned on in order to give power to the pump. The switch can be turned off, which in doing so will turn the pump off, even if the hygrometer reads low. This is in case I want to adjust the plant for even watering. If the soil is sufficiently watered, the sensor will read high and the peristaltic pump will turn off. Here, the hygrometer is put in the soil and the on and off switch is turned on. The pump turns on in increments of 5 seconds to allow the water to diffuse evenly in the plant. The flow rate is 0.25 milliliters per second, which is the ideal flow rate for this size pot. As you can see in the clip, the red LED light is on to indicate that the soil is still dry and the sensor is below the moist threshold assigned to the Arduino. In this clip, the plant had already been receiving water for about 50 seconds. The red light going off and the green light turning on is to indicate the plant was sufficiently watered, as you can see right here. To ensure the validity of the hygrometer, I purchased a commercial soil moisture meter. This particular plant is a calathea, and it likes to be moist, not wet, so I took that into consideration when coding and tailored the moisture levels accordingly. You can see from this moisture meter that it is right in between wet and moist. I decided to try using a succulent with my project, but before doing so I had to change my code some in order to best fit the needs of this type of plant. You can see everything works the same as it did in previous videos, except it takes less time and water for the sensor to turn green. This video was taken after the plant had already been receiving water for about 25 seconds before the plant was sufficiently watered. To ensure the validity of this succulent setting, I tested it using my commercial moisture meter. This type of plant requires less water than most plants, and it prefers to be moist. As you can see, it falls right in the middle of the moist threshold. I would much rather be able to switch plant types by just a push of a button instead of having to go in and recode the Arduino. It's definitely something I will consider moving forward.